Welcome back to BAS 110. We're going to look at a couple examples 4.6 through 4.10. Now, in the previous videos, we talked about describing data, because that's what the whole chapter is about, is how can we describe data or descriptive analytics. And we talked about one way to describe a set of data is to tell people where it's located, what its average is, or the mean, what the median of the data is. We talked about the mode. We talked about different percentiles. And all of that is to explain to our audience where the data is located. This next set of tools to describe data talks about how dispersed the data is. So here we've got three sets, A, B, and C, all with the same mean, all with the same median, all with the same mode. So the location of the data is all the same in these three sets of data, but yet each data set is very, very different. Some is not very dispersed. For example, A, the range is relatively narrow, where C has a very large range. So we'll talk about ways of describing data by how dispersed the data is. Basically, how wide it is, which is the range, how much variance it is, and we'll introduce something called the standard deviation. So here's our old friend, the purchase order data. And again, we're going to look at the cost per order. So let's slide down, and here's what we calculated in previous sessions: the mean, the median, the mode. Now let's calculate the range. Well, the range is just from the highest score, or the highest value, which is the max, compared to the min. And you take, in this cell, you can see for the range, we just subtracted the maximum from the minimum, and that tells us the range of the data. So if we go back up to our chart, the range of C would be from the lowest score to the highest score. The range of A would be the same thing, from the lowest score to the highest score. It conveys to us, so for a class taking a test, if the range is from a 70 to a 90, we know something about the dispersion of the data, versus if the test scores ranged from a 30 to a 100. Very different dispersion and very different pictorial of what kind of data we have, way to describe it. So the range gives us some information. In this case, it's 431, excuse me. Next, we have what's called the variance. Okay, now the variance, what this does, and this looks very complicated because it's Greek letters, it's X1, as you can see, is each student's score. In this case, is each amount, minus what we said the average was. So what? Divide, and we square that, and then divide by the number of scores we have. And this symbol here just means you add them all up from the first score. So what's going on here is we're taking this very first cell, comparing it to the mean. Now, the reason we square the numbers is if we just went through, if you think about it, if we just went through and subtracted each score from the mean and added all of those up, we would end up with zeros, because the positives and the negatives would offset each other, because that's what the mean is, the average. So in our equation to calculate the variance, we're going to square each one of these numbers to basically make it a positive number. So what we're doing is we're going through and taking every single order, comparing each order to the mean, adding all those up, and of course we're squaring it so we get a positive number, and then we're dividing it by n, the number of students. Now, you could go through and you could write equations for each one of those and sum it all up, and you could do it in Excel, or you could just simply go to what's called the VAR formula for variance, and you can look it up here. Excel changes from version to version, so sometimes it's called var.s, some versions it's called var. What you need to do is just go up here, and I usually go to the statistics, and I go down here, and I go to variance, and it tells me based on a sample. That's what we have. We don't know the entire population. In an earlier video, we discussed the difference between knowing the entire population as opposed to just knowing a sample. Well, this was a sample. If we knew the entire population, it's this vars p where you know the entire population. In this case, we just have a sample. So we would do this equation, and then it simply says, tell us the range. And our range for this is all of these scores. And we would hit OK. And there we would get our number. And we might want to make this number a little more presentable by putting some. And there you see you get our 890. Now this is somewhat helpful, but it can be a little bit hard to understand. 890 million is my variance. Well, to most folks that doesn't mean a whole lot, at least not to me. And in large part because we squared all of these numbers, right? So it's extremely large. So what a lot of folks will then do is what's called a standard deviation. Now there's two equations. One is a standard deviation when we know the population, and the other is a standard deviation when we only have a sample. We have a sample mean. We don't know what the population mean is. We only know what our sample mean is. So in the case where we know the population mean, we use this equation, standard with a p, standard deviation with a p. We put in our range and we calculate it. In this case, we only know a sample, so we use standard dev. And I think in older versions they might have put the s, but in this version it's standard Ds. You get about the same number. Notice you get a little bit larger standard deviation when you don't know the population mean. And that makes sense to me because what you're doing is you're saying, well, I'm going to, since I don't know what the population mean is, I'm going to assume a close approximation of that is my sample mean. And that's why you have the n minus 1 versus the n, because you're adding a degree of freedom, because you really don't know. In this case, you really know what the population mean is. In this case, you're making an assumption that, well, let's assume the population mean is the same as my sample mean. That's why you get a little more degrees, you get more degrees of freedom, which causes your standard deviation of the sample to be slightly larger than your sample standard deviation of a population. But that's how you calculate your variance. That's how you calculate your standard deviation. And this is telling us the standard deviation is 29,842. And in the next video, I'll show you the power of knowing that standard deviation. Hope this helps.